single favor and just grab your lighting book. If you guys remember the first chapter 1 through 4 or 5, we talked about two major methods of doing calculation, right? We talked about the point-to-point method, and we also talked about the average method. The average method is the poor man / woman method, and the point-to-point method is the rich man / woman method, meaning it gives you more information about your lighting system. And we told you doing it by hand is so yesterday, and you're not going to be doing it for living by hand. So the reason why we do it, just to get you to understand the gravity of lighting calculation. Can I have thumbs up, Chad? We understand that this is just to understand the gravity of the lighting calculation. Okay, so we did by hand. This chapter 6 talk about floodlights. Floodlights, mostly outdoor lights, mostly thousands of lumens. You have a big light, as you guys know, instead of talking about hundreds and thousands of lumens, as in 2,000, 3,000 lumen lamp, you're talking about 9,000 lumen, 12,000 lumen lamps. A lot of lights coming out of this fixture. For these fixtures, they have a few things for them. So if you guys do me one little favor, again, I'm so sorry for my bad handwriting, Chris, but I do have this in a PDF file, and if anybody wants a translation after you print it, how to read it, I will read it for you. But hopefully, if you're in my lecture and you're looking at your book and you're looking at the PDF file here, hopefully, you'll get it. So moving into, guys, chapter 6. Let's go all the way to chapter 6 with me, if you do me a little favor, okay? Okay, so the floodlights, guys, so we're talking, I want everybody to know that we are talking about the floodlights. So the floodlights, the difference between a floodlight, Chris, is you have a big light mounted probably 30 to 40, 50 feet, and it's shooting a lot of lights. Now, the smarter than Chad decided if you have this type of fixture, the calculation is going to be still. There are two ways of calculating. You can do the point-to-point calculation or the average calculation. Either way, instead of using the nadir point, guys, remember that nadir point that we said if you have a fixture, not floodlight, the point right underneath the fixture at 0 from the vertical, that's called nadir point. Instead of a nadir point for floodlights, they have an aim, the aiming point, or they call it coefficient of utilization. Let me get rid of my email. What is this? So that's really the major difference is you have a point here where you can aim your fixture. I want you guys, if you pay attention to that, you have a 30-foot pole, a floodlight at the top of it, shooting light. I'm aiming the floodlight to shoot right at this point, and then you take, they call it a coefficient of beam utilization. When they aim the light, based on where you are above the line of aiming the light, it becomes a coefficient of utilization. So if you go higher or lower than this line, this angle, can you guys see this angle? I'm going to call it, I'm going to call this angle Q. Here's my Q1 and Q1, basically above or below. So if you go in either direction, this way or that way, you're going to get different type of lights as they hit the floor or the ground. Long story short, they came up with a couple of definitions. So the first thing you need to know is when you do a calculation for a floodlight, you're going to find the number of fixtures, how many fixtures on this floodlight, 1, 2, 3, 4, 5, most of the time 1, multiplied by how many lumens coming out of that fixture. That's easy, usually in 7,000, 8,000, so forth, multiplied by the coefficient of utilization. This coefficient of utilization is a function of the fixture itself. So the fixture has its own coefficient of utilization, multiplied by coefficient of beam utilization. There's a CBU called coefficient of beam utilization based on where you are in this angle from that little aiming point here or aiming line. There's a factor that you have to multiply. basically you're going to get more or less lumen based on where you are above or below this line of aiming. That makes sense. Here's my line of aiming, that red thing. If you go above it or below it, you're going to get different values. And if you divide it by the area, you're going to get the average foot candle for this floodlight. The average foot candle for this floodlight. As you move through the definition, guys, this is the only thing I want you to take from this chapter. We'll take an example in a second here. The first thing you need to know is CU stands for coefficient of utilization. That's like an efficiency factor you attach to the fixture. CPU, coefficient to beam utilization. It's you're going to see how they define it. Actually, they take the light that comes out of fixture divided by the lumens that comes out of fixture divided by the lumens that hit the actual surface that we need to lit, that playground or whatever. This factor is called coefficient of utilization. LLD, lamp lumen depreciation factor, and LDD, lumen dirt depreciation factor. All these factors, guys, especially these two, are factors that they can, I mean, you can increase it from 0 being really, really bad into 1 being excellent. So, any comments about the formula? So, summarize. You have a floodlight. The only thing I want you to do, guys, know about it is you have a floodlight. You mount your floodlight usually high instead of 10 foot, usually 30 foot or higher. It's shooting light, and you can direct the light based on this line here. That's the aiming. And then the angle above or below this aiming line can get you more or less lumens. So when you find the lumens, you take the number of fixture, multiply how many lumens in each fixture, multiplied by the efficiency of the fixture CEU, the coefficient to beam utilization, which is a factor of how much of this light's coming out are actually reaching the ground instead of going somewhere in the sky. And of course, LLD and LDD, these are the rating factors. Divide everything by the area. Any question, guys, about this formula? That's all what I need you to do from this chapter. Take this average method. Average method. Any question? So what they're telling you, guys, instead of using the nadir point, remember that nadir point right underneath this fixture, they're using, because you can aim these fixtures, they're using that aiming line, that red line, and they're going to assign a factor that's called coefficient to beam utilization based on the angle that you are far away. How far are you from this aiming line? You're going to see in a second. One more time. Any question, guys? Anything you want me to read with my nice handwriting? Any question? So let's just, I know you're taking a few seconds to draw that one. Again, this will be PDF colored and put on the network for you. Okay, so who cares? We're going to use this formula to do calculation. But everybody understand what the concept of a floodlight? There's the only really thing that we didn't touch before is that aiming line and going above. Here's that my aiming line. Actually, we're going above the aiming line or below the aiming line. That will give you more lumens or less lumens. And the smarter than Chad came up with the curve. Okay, because we know everything, we have gone over every single thing in this formula. I hope so. The number of fixture, everybody knows what number of fixture. The lumens out of fixture, these are manufactured. The coefficient of utilization, that's also manufactured. LLD and LDD also given based on the environment that you're in and the fixture. We're going to define the CBU, coefficient of beam utilization. This is how they define it, actually. If you have lumens hitting the surface divided by lumens emitted from the luminaire fixture. Let's take a quick example. So if we have a fixture, take this example. If I have a flood fixture, floodlight, and my floodlight is giving me 10,000 lumens. Okay? Makes sense? 10,000 lumens, just for the ease of installation. And then the lumens that reach the area that I want to lit. So here's my light here, standing over here, and I want to lit the area. around this light. This is the area that I'm going to lift in every direction. Let's just say, okay, just for the ease of installation. And here's my light coming out of that. 10,000 lumens coming out of it. If I have 8,000 lumens hit the ground, what are we going to call it? Hitting the ground. Hitting ground. Ground. Okay. So 10 coming out, 8 hitting the ground. So if you find the CBU for this picture, how do you do to find the CBU? You take the 8 that's hitting the ground, divide it by the 10 that's coming out of the fixture, and that will get you a 0.8 coefficient of utilization. This has no meaning other just to explain, guys, what a coefficient utilization is. How many lumens coming out of the fixture compared to how many lumens actually reaching the place that I need to lit, because some lumens are going to go visit the other planets and going to go all over. Okay? Most of the time, my understanding, and I'm not an expert in lighting, CBU, you calculate it based on the orientation of the fixture. You don't calculate it based on what I showed you. This is just a very simple example to see what they mean by coefficient of beam utilization. You have a beam and you're directing it, so above or below this beam will get you a different CBU. Okay, any question, guys? Can I get you to tell me two things? Number one, Chad, we understand this formula, and on the test we'll bring it with us. Number two, we understand what the aiming line is, and going above and below the aiming line give us a factor called CBU. Can I get you guys to understand these three things? The formula, the line, the red line, go above or below the red line, angle-wise, can get you a factor that's called CBU, coefficient of beam utilization. For the test, here's what you're going to do, Ashley. Chad is going to throw that CBU at you and all this information and say, okay, calculate what's the foot candle coming out of this floodlight. Done.
The last one, the last line there, what do you write?
This one?
The last line.
This is LDD, believe it or not, this is a D.
What does it mean?
What does it mean? Luminaire dirt depreciation factor. How often you clean the luminaires? If you clean them less often, this factor will be less. If you clean them more often, this factor will be more, as in more in percentage, 0.9 versus 0.1. Any question, guys, about this one? Can I switch into an example to use it? Okay, here's the CPU. All right, so let's take this example. This is from the book, directly from your book. If you guys look at this floodlight, look at these floodlights. I have 250 watt high pressure sodium. Can you guys see that? This is, as I said, directly from your book. I have a 30-foot, everybody can see it, a 30-foot pole. I have a floodlight of 250 high pressure sodium. This light is giving me 27,000 lumens. Can you guys see why they call them floodlight? We're not talking about 1, 2, 3,000 lumens. Like this one, each lamp will give you 3,000 lumens. So if you have 3 lamps, that'll get you 9,000 lumens. Look how much that fixture is giving you by itself. It's giving you 27,000 lumens. That's what a floodlight is, a huge amount of lumens coming out of it. Okay, so one more time. I have a 25 watt high pressure sodium, 27.5 thousand lumens coming out of it. The coefficient of utilization coming with the fixture is given as 80%. The area that I need to lit is a square area of 40 by 40, right? I put that fixture right at the edge of 140 by 40, and I want to lit this 40 by 40 area, right? 40 by 40 feet. Lamp, the dirt depreciation factor is 0.8, and the lumen loss factor is 0.8 and 0.7. So the LLD is lamp lumen depreciation. The lumen depreciation, the lamp lumen depreciation factor is 0.8, and the luminaire dirt depreciation or dirt factor is 0.8, 0.7, given. Any question, guys, about the given? Okay, here's where we're going to draw that one. I have a fixture. The red line is my aiming line. The red line is my aiming line, given by when you aim that fixture. And then going above will be plus 10. If you go plus 10 or minus 10, that will get you more, or basically more or less. It will give you the coefficient to beam mineralization. The coefficient to beam mineralization. So to make it easy for you, just to make it easy, yes sir.
Please how to determine your aiming target, the aiming point. How do you determine?
Let's say if Chad had a beautiful picture of himself down there, he would want to floodlight or accent that photo or something on the wall. That's where you use floodlight. And then that would be your center point for your CPU.
So when you have a big, thank you, Nick. You have imagine if I am a fixture, a pole, and my head is a fixture. The fixture is going to be shooting light, and I want to aim the light in the middle of the parking lot. If you have a 40 by 40 area, your aim is going to be most likely, and you put it at one side of it, 40 by 40, you're going to aim right in the middle of that square. That's your aiming point to get you the best distribution, more or less, in the whole area. Now, if you go, see where I'm here, I'm pointing right to the center of that square. If I go further or lower, it will give me more or less lumens. Based on that one, will give you a beam utilization factor. Okay, so this is what we're giving. I'm giving you guys an example. I want you to do it based on plus or minus degrees above the aiming point. You need these degrees, by the way. Without these degrees, you cannot calculate the beam, the coefficient to beam utilization. I'm going to make it easy for you on the test. I usually will give you the beam. So based on plus minus, if you go to a curve, there's a curve in your book, guys. A curve that looks, this is dark area, and this is the lit area. If you guys go in your book, you're going to find that it looks something like this. So if you cross-reference the angle plus and minus, if you cross-referencing it on this side will give you, and I'm looking at, I don't want to draw it because it's right in your book on page 59. I don't know if you guys can see that. If you go 10 and 10 and you cross-reference it, you're going to get a beam utilization factor of 0.2. Can you guys see that? There's a 10, plus 10 or minus 10. If you go all the way down and cross-referencing it to the y-axis, you're going to get 0.8. Everybody can see where you find that? 0.8, I'm sorry, 0.2. So for this fixture, based on this orientation and given, my beam utilization is going to be 0.2. 0.2. Okay, now plug and play. The rest of it is plug and play. For the tests, guys, here's what I'm going to give you on a test. I will give you the angles, exactly like I did, plus or minus, and find me the beam utilization from a curve. So you will have a curve, Jackson, my friend, you will have a curve like this, and I'm asking you to find the beam utilization for this fixture. Every fixture has a curve like. So for example, if you guys go to 20 by 20, right, 20 plus or minus, Chris, can you verify if I go to minus 20 and plus 20 degrees above and below the aiming, my beam utilization factor is almost 0.3? Everybody can see how to read that one, 0.3. If I go, guys, to 40 by 40, my, so 0.35. Everybody can see that? If you go 40 by 40 way, then 0.35, okay? So that's kind of where your beam utilization factor is. All right. So, Jackson, we found the 0.2. Any question how do you find? Can you guys give me a thumbs up, Chad? We know how to find the coefficient of utilization from the curves. 0.2. Good. Then the rest is just plug and play. Very easy. Okay. The formula says number of fixtures multiplied by the lumens multiplied by the beam coefficient to beam realization, lumen depreciation, dirt factor divided by the area. Now, this is a very simple algebraic equation that you can plug and play. How many fixtures do I have, Rob? One? Only one. You could have two heads or three heads there. You just add 2, 3. How many lumens coming out of this big floodlight? 2700, 27.5 thousand. What's the beam is 0.2, meaning only 20% out of this floodlight is actually going to hit the surface area that I needed to let it go, based on the angles that I'm interested in. The lumen depreciation factor given 0.8, or is it 0.8? What's the 0.8? And there's 2.8. Do I have an extra 0.8 here?
Like the CU is one.
Oh, the CU, yep, thank you. There's a CU is 0.8, and the lumen depreciation 0.8, and the dirt is 0.7, and the area is 40 by 40. Now the rest, when you plug these numbers, the rest is piece of cake. You do them all, and you got yourself a 1.54 foot candle. Is this good? We're talking about area. That's good. I mean, parking lot area is no problem if it's a parking lot.
Chad,
Yes, sir.
the height included?
Yes, the height is represented by the beam utilization factor that you get here, and by the lumens. So it has to be a function. All this information, if you can see, I'm using the example that we have, which is yes, it's going to be a factor. Yes.
So this graph is based on a certain height?
Based on a certain height. Otherwise,
Where is that indicated in the
it's
graph?
not indicated.
Oh, no, it says mounting height of 15 feet.
15 feet. Where does it say? Where are we here?
Right above the graph,
Okay.
you just take your eyes and go up, you'll see ISO foot candle distribution, you'll see mounting height.
Yes, thank you.
15
Thank
feet.
you. Now I threw the 30 here, but yeah, you change the height, you change the 30, it will give you different. You're absolutely right. So if you can see, guys, thank you, Chris. This graphic all here is based on the height of every fixture. Based on its height, the beam utilization will be different. The luminous distribution will be different.
So you'd need data from various.
Yes.
components.
Or a factor that takes into you. So most of the time, they give you, if you mount it at this height, you have to multiply by this factor. Yep.
This is part of the photometric data. We're
Yes.
looking at a software piece. I looked at those files.
Yes.
There's a file of what are called arrays. We have strings of numbers that then would correlate.
Yeah.
Match up with something.
If we have, thank you, Chris. If we have the software, obviously you can grab the IES file for the software and throw it, and you do the calculation like we do in any other fixture. Yes, sir.
CU is given by you, right?
Given by the manufacturer. Now, well, yeah, on the test it will be given by me, but it's given by the manufacturer for the fixture. Okay, that's the only thing I want from this floodlight. Any question, guys? In the end of this chapter, they do floodlight on a billboard, and there's a lot of angle calculation. Do it on your own. I don't think it's worth putzing around with that. If we have a billboard right now, Nick, you know what we do? We use visual to do vertical foot candle calculation in it. Piece of cake. You direct, all what you have to do, direct your fixture and do the calculation. It's not worth doing the hassle. Okay, any question, guys, about this? Can I get you to say, Chad, yeah, we understand it? The only really new concept is beam utilization factor, coefficient to beam utilization. Okay, so that's all what I want to do, guys, about okay, utilization. Let's see, BU curve. What we have done here, Nick, is called the average method. You can use the same thing for a point-to-point method. Then you need the height, and you need the calculation that we did before, and you multiply everything by CBU. For the floodlight, we're just going to use the average method. Okay. CB equals something like that. Okay. Any question, guys, about this? Can I just get you to say, Chad, we got the coefficient of realization factor? And if you give me an angle, I can, from the graph, find it, plug the numbers, and find what the foot candle that I need. Okay. That's all what I want you guys to know about this chapter. If you go to chapter 7, please. Chapter 7, point method of floodlight calculation. Now, chapter 7 takes, remember the chapter 6 talk about the average. If you want to take one thing out of this book, take the two methods. One is the average, the other one is the point to point. Which one is the most superior? The point to point. Why? Because it gives you foot calculation at every single point in your area, plus the average, plus the maximum, plus the minimum, plus the ratio between maximum and minimum, and so forth. Okay, chapter 7, guys, take the light, the same light that you have, floodlight calculation, and does the point to point method in it. Does the point to point method in it. The point method of the floodlight calculation. And if you look at the formula that they're using, are we familiar with this formula? Isn't that what we did, guys? You take the CP at the right angle, cube the cosine of that angle, multiply by the lumen depreciation, by the dirt depreciation, and divide by the square of the height of the fixture, and good to go. Good to go. Exactly like we've done any other fixture. Exactly like we've done any other fixtures. So the CBU does not play any role if you're doing the point-to-point calculation. Okay, have you guys noticed that? If we're doing a point-to-point calculation of floodlight, the coefficient of beam utilization is not a factor because we already factored the angle, didn't we? We already factored the angle. We picked the angle through the cosine. They use, and don't ask me why, Chris, they use the CBU with the average method because the average is looking at the whole big picture, the average. The point-to-point, as long as you know where it's pointing, you already factored the angle for it.
Your MH.
Mounting height, H, mounting height.
So mounting height is not the distance of the beam.
No, mounting heights. Yep. They go exact. Chris, that's what I tested you guys on, the same formula. So, two things. If you're doing point-to-point calculation, exactly what we have done in the past. If we're doing average calculation, you have to take into consideration the coefficient of beam utilization for that fixture. Okay, let's take an example. Suppose that I have, here's an example I have. This is coming from page, let's do it, this is coming, I believe, from page 59. So at 65 degree, I have 3, okay. So let's just, I'm going to draw that one for you, very little here with my nice draw skills here. Here's my fixture, and here's an angle, and I'm going to do the calculation at this point. I'm going to call it point 1. And the height of this fixture, I'm going to use the same calculation here, 15 feet. It's a floodlight, and the angle, just because I'm lazy to give you the angle, just because I'm giving you an angle Q of 65 degree, right? I'm asking you at 65 degree, can you please find me the foot candle out of this floodlight? Normally we don't do that, right? We give you the distance and then you find the angle. So just for the illustration, we're giving a fixture at 65 degree and the height of 15, and my fixture is given, guys. I need to find the foot candle. So if you go to page, this is page 59 and fig 6.1. If you guys go to page 59, fig 61, actually, my friend, at 65, can you guys see at 65 degree how many lumens we can get, right? We can get 3, 8, 6, 7. 3867. Cosine the angle, piece of cake, multiplied by the 0.8, 0.7. These are given, and I'm giving you, these numbers are given. 0.8 as lumen depreciation, and dirt is 0.7.
And where did 30 come from?
The 30 come from, I single-handedly decided to screw up the calculation and put a 30 here, knowing that the curve is not really for 30. So if it's for 30, it's going to be different. Yeah. Why don't we do it the right way? And Chris is going to do the calculation for 15, just to be consistent. 15 feet. Can you do the calculation, Chris, for 15, please? 15 to the power 2. So we can be more precise. Do it on 15. Anybody can verify Chris's calculation? So just to be consistent with the data that we're pulling from, otherwise we'll be screwed. 15 raised to the power 2. Any question, guys, about this is exactly what you did in the test with me. Nothing new. You have the curve, you find the candela power, you cube the angle, cosine of the angle, multiply it by a couple of derating factors called, you can call it guard factor plus the dirt depreciation factor. There's so many terms, guys. The guard, you know what a guard is. That's standalone factor. Dirt depreciation factor is another factor. Lumen depreciation, dirt factor is another factor. Lumen depreciation factor is third factor. So all these, every time you have a factor, what do? Just multiply at the top. Keep multiplying it at the top here. Chris, did we got an answer?
No.
Anybody else got?
0.7.
0.7?
7/10 of a foot cube.
0.73. It should be more though. Huh. Yep. So it's 0.73. 2, you got it? Okay. 0.3, somehow it looks strange. And I'm going to do it. I'm a doubting Thomas, like. I have 4.
4 foot candles?
Yeah. Anybody? What did you all guess?
Tried it 2 different ways, and then the exact number.
Okay. Anybody came up with something? I came up with 4. Maybe I am wrong, but I can't be wrong. Okay, cosine. I didn't cube the cosine. I know why. I didn't cube the cosine.
Yeah, I got the 0.07.
I didn't cube the cosine. Yeah, you're right. Okay, so 0.73, done. That's the foot. That's for an outdoor light. It's not bad. Remember, we need a minimum 0.5 for an outdoor fixture. That's not bad. Any questions about this? This is really what chapter 7 is all about, using a floodlight exactly like we use any one of them. Any question? I have another example, I think, about vertical. Floodlight calculation. Chapter 8, guys, the same thing. Point method of floodlight calculation. We just went through that one. Curve utilization. Okay. Any question, guys, about the calculation with a floodlight point? Very similar, very simple, straightforward, no gimmicks in it. Any question? Okay, let me go to what's in chapter 8, guys. If you go to chapter 8, please. It talks about vertical surface. You guys have done vertical surface for me. You put the picture here, calculations on the wall, and it calculates foot candle at every point, 2 feet by 2 feet on your wall. How do you do that one? With a floodlight. Like a billboard. How do you do a billboard with a floodlight? You have two methods. You have the average method and the point-to-point method. The point-to-point method, guys, is very similar to what we have done before. We're going to use the sign instead. We're going to use a sign instead of the cosine. When we use the average method, you're going to use the same. We're going to go back into the back. Look at this. Back into the coefficient of beam utilization. We go back. Every time you use a floodlight, you have to kind of, as an average calculation, you have to find the coefficient of beam utilization. Okay, take this example. I'm going to verify with this example, my friends. If you look at, I have a light here. I need to lit this wall here. This wall is, what is it, 10? It's a wall of 10 by 20. Imagine 10 by 20 wall. A wall is 10 by 20, and I need to lit this wall. And I'm going to use the average method. Here's the fixture that Chris have picked. He picked 150 watts, say metal halide. And he picked the lumens coming out. This baby is 15,000. Coefficient of utilization is given 0.8. Dirt is 0.9 because we're clean. Maintenance factor, now we're adding a maintenance factor. Maintenance factor for this fixture. All these, don't get confused between what's M. These are all factors. Maintenance factor, I believe that's what they added on that one. Maintenance factor is it's 0.7. Or lumen, you can call it lumen depreciation factor, maintenance factor, whatever you want to call it. Okay, and what do we need to do? We need to find the average foot candle calculation on the surface. I'm giving you that the area is 10 by 20, and the coefficient of utilization for this fixture at this location with this type of watt is 25%. So instead of, and if you can see in chapter 8, they have, they did the same thing. They have a way of calculating the coefficient of beam utilization based on where you point that fixture, the beam out of that fixture. I'm going to spare you, my friend. Here's basically the beam that's coming out of here. I'm going to spare you the calculating the beam utilization here. So here's above and below the beam. So I'm sparing you finding the CPU, and I'm giving it to you as 25%. Okay? Calculate. What do you do? Calculate. You're going to do the formula. I'll go back here. Here's the formula. Oops. We have 16,000. Is there? Okay, we have okay. So here's the formula that we're going to be using for the average on the wall. Lumens multiplied by, don't forget, coefficient to beam utilization, all the other factors and the guards and everything else. Here's the lumens coming out of the fixture, multiplied by the beam. This is my favorite because we're doing average, we have to have the beam. The rest of these are a bunch of junk that you can add between the coefficient of utilization, the LDD, MF. Now Rob is looking at me, Chad, what if I don't have the MF? What do you do if you don't have an MF? You assume it's what? 1. Ignore it. If they don't give you any of these factors, you just assume it's 1, right? It's not an issue. They give you the factor, just put it in the formula. Okay, when you do all your calculation, I don't know, Chris, if I did it right, you're going to get an average of 10.1 foot candle. Average 10.1 foot candle. 10.1 foot candle for this fixture. Any question, guys, about this? Exactly like we did the horizontal. Now, the only difference as how to calculate the coefficient to beam utilization on a vertical surface. And I'm going to spare you the putzing around with it, and I'm going to give it to you. I tell you, here's the fixture mounted right close to the wall. Here's the wall area, and here's the coefficient of utilization that I need you to maintain. And could you please find the foot candle on this billboard to maintain the billboard? I don't worry too much about it, guys, because with visual and AGI and all these softwares, it's getting very, very easy. You guys did it in the conference room. Was it the conference room, Nick, that we did? We put our lights on the surface, and we put the calculation zone, and we did the calculation in it. So it's but I want you to know, if you have a floodlight, that's how they do it. So what's the main ingredient here on the average? The main ingredient is that, baby, for vertical. You need this one for the vertical. And that's what makes the difference. And if you look, a lot of people, my friend, they have the curves, how to calculate coefficient of utilization for this fixture at a vertical surface. Now, Phil, if I ask you to do the same thing with a point-to-point method, the only thing you drop out of the equation is coefficient to beam utilization, because you know the angle, and you do the calculation exactly on the surface though. And you use, and then you use the sine. Remember how we use sine? Instead of cosine squared, we use the sine. Cosine to the power 3, we use the sine squared. Okay, here's where we're actually having it here in a second. I'm going to take the second example. Okay, one more time. If you have a billboard, you need to lift the billboard. There are two ways of calculating it. It's called vertical foot candle calculation. One way is the average. With the average, Nick, my friend, with the average comes a tiny son of a banana coefficient of utilization called CBU. This is the single most important factor when you do the average for floodlight. You need to find the CBU. We have a bunch of curves based on the angle that we need to achieve. We can find the CBU. In my example, to get me 0.25, I'm actually looking at probably 0.25. I'm probably looking at 2.5 plus or minus. So I'm looking at 25 degree plus 25 degree minus. If you take a 25 degree plus 25 degree minus, guys, and look at it, Dustin, in this curve, cross-referencing it, that will give you close to 0.25. Close to 0.25. Okay? I spared you the calculation here. And then you plug in all these formulas. Any question, guys, about what's given? Okay, so you go back here. Here's my floodlight lumens. Now, I'm sure Rob sitting there said, Chad, what happened to the N here? There was an N. If you have two fixtures here, what do? Multiply it by 2. So 16,000 multiplied with the beam, multiplied by all the other factors. We have a maintenance factor here. This time we added a maintenance factor. And you got yourself a 10.1. Any question, guys, about the average? Any question about the average? Now let's do the same example, a similar example, based on the point-to-point method. Based on the point-to-point method. Okay, take this. We're using this is okay, Fig 5.9. 72. Is that what we're using? Okay. All right. So we're gonna do the foot candle calculation, guys, based on point-to-point method. The most important thing for us to understand is you need the CB, piece of cake, and instead of cosine, now we have a sine, and instead of and then we put all these junk of factors, whatever factor there, you drop them in there, and divide it by the distance squared. The distance squared. No cubes, unlike I told you, no cubes here, nothing. the distance squared. Okay, take this fixture. Here's the same fixture that we have, guys, 20 feet away. And I need to find the foot candle right at this point. Right at this point. One more time. Can I get you guys to give me, say, Chad, yeah, we know that the formula for the foot candle in a vertical is actually this one. Can I get you guys to, yep, it's the formula for the foot candle on a vertical surface is this one, right? The sine divided by the square of the distance with a bunch of other factors. All right, so let's do the calculation as an example here. I have, I decided to find, I need to find the foot candle at a point 10 feet off the ground, 10 feet off the ground. So do your geometry. I have 20 and I have 5. If you do it, this will be 20, right? So when you take 5 out of 10, or for that fixture, it'll get you 5. From the Pythagorean theory, my friend, you're going to find, or whatever theory they use, you're going to find, we need D. We need to find D. In this formula, we need to find D and Q, right? Because I need Q and I need D. And I know Chris is going to go there, mix them together and find a formula. D and Q. So to find D, guys, you know, you square the two sides and add them up. You square each side, add it to the square of the other side, and take the square root of it, right? Pythagorean theory. 20 squared plus 5 squared, take the square root of it, 21. So D is 21. Piece okay. So I know that D is 21 feet. So I can plug it into the formula. The second thing I need to find, guys, is the sine of the angle. Sine of any angle, William, my friend, the sine of an angle is the opposite over the hypotenuse from the old days. Unlike the cosine, the adjacent to the hypotenuse, or the tan, the opposite over the adjacent, right? Everybody knows what the opposite of the angle. Here's the opposite. This one is opposite of an angle, if you guys forgotten. The opposite side of an angle over the hypotenuse is called the sine. So here's the sine, 20 over 21, get you 0.95. Sine 0.95 is give you 72, you have to have sine inverse. I don't know why we want to do the sine inverse though.
No, you got what you need.
You got what I need right here from the sine. So I don't need to find the angle. Oh yeah, I need to find the angle because I need to go to find the CP.
Oh, okay.
Yeah.
Fine.
So here's my sine. Then from the sine, I need to find the angle to find the CP. Okay. Then my angle is 72. If you guys take the 72 to Fig 5.3, page 50, that'll get you 194, right? Anybody can see that? Page 50. Is that true? Page 50. Page 50 for 72. I don't have a 72, I have 75. So I went to 75 because it's closest, 194. Everybody can see that, guys, page 50? Fig 3. Okay, so 194. Then all what you have to do now, put 194 here. Take sine 72, multiply it by 0.8, 0.7, divide by 21 squared, will get you 0.25.
194.
Yep.
Oh, okay. Sorry.
The CP. Yeah. One more time. Any question, guys, about this? This would be how to do a foot candle calculation, not just floodlight, any light, based on the vertical. So really, the key point here is to, for this triangle here, to do the math on this triangle, right? Now in the test drop, here's what I want to do for you guys. I want to ask you at least 2-3 points. I'll ask you find the calculation for this point here. Right? The angle is 90. We know it now. Find the calculation instead of 0.5 and a half. Find it maybe 0.2 here. And you just repeat the same calculation. And a lot of people, my friend, this formula, bring it with you. CP multiplied by the sine, because we're doing vertical, and all the, I know that might be confusing, guys, but because sometimes we say M, F, M, G. Don't worry, whatever factor I give you at the end, slam it way at the top right here. The most important thing is really the CP and the sine Q. All the others are derating factors. If I don't give you the MF and GF, what do? You assume them. One, we clean really good, we maintain the equipment good, we change the bells good. Lamp lumen depreciation factor is really good because we relamp more often. So, any question, guys? Can I get you to tell me, Chad? Yup, thumbs up. We know that one. Yes, no, in between. Why don't we take a, I'm gonna go take a 5 minutes break, my friends, and then I'm just gonna go take another example for the same foot candle calculation. We'll do it together, and then we'll call it a day for the lecture. Should we have 5 minutes? For this example, this is the same lighting fixture that we talked about before, the same characteristics, everything is the same, except we have a billboard and we want to lit that billboard with this floodlight. The height of the floodlight, the fixture is 10, and the distance is 5, and I need to find a foot candle at 0.7, at the vertical 0.7, at the vertical 0.7. Let me just write the formula here, and then we'll go through the whole spiel. So my foot candle vertical, V for vertical, equal candela power multiplied by sine Q. This is the most important factor. And then multiplied by a couple of others. Let's just say we have a maintenance factor as well as a guard factor. And everything is divided by the distance raised to the power 2. Any question, guys, about this? Just an example. The most important thing is the CP and the sine Q divided by D, and then you add a couple of multipliers. I like to put them between brackets, maintenance factor and guard factor. Maintenance factor and guard factor. Let's put a couple of inputs about this fixture. I want to use a fixture in page, same fixture. I want to use the fixture in page 50, and the fig for this fixture as fig 5.3. Fig 5.3. Without this information, Chris, we're doomed. Without the page and the fig about that particular fixture, we can't find any calculation for this fixture. You just can't find a calculation for this fixture. And if you guys go to this page, it says it's actually a 70 watt high pressure sodium. So this fixture is given as 70 watt high pressure sodium. High pressure sodium. Okay, so I'm interested in finding this calculation. Any question, guys, about the given? Let's get you the guard factor.
When did it bump up to 75?
That's what the 8.
Oh, it's 71.
75. It pumped up yesterday when I was sleeping. So we're gonna put 70. 71. Thanks, bud. 71. We're interested in the concept. Okay, 70 watt. You can call it any watt you want as long as we have the information about it. Okay, so we need to do the calculation, guys, at this point. The most important thing is to do a triangle like we've done. As you can see, this is a 5 foot. And if you take 7 from the bottom, you're left with 3 right here, right? So we are looking at a triangle of 3 by 5 sides. And I need to find D is the distance. So doing the trig. So if I find D and I find Q, I can find the CP, maintenance factor and guard factor. I want to give you these. Maintenance factor, those guys are very clean. So we're going to put 0.9. And guard factor, this guard is really good. So we're going to put it at 0.85. Okay, given. Okay. Any question, guys, about the given? First thing you need to do is find the Q. To find Q, find D. So step number 1 to do the whole calculation is find the D. D equal a square root of Pythagorean theory, 3 raised to the power 2 plus 5 raised to the power 2. And that will get you, I need somebody with a calculator, will get you 9 plus 25. What's 9 plus, that will square root of 34, right? What would that be? Did you do the math right? Yep. What's square root of 34? 5.8. Thank you. 5.8 feet. Any question guys about the distance? We found the distance. Step number 2, second thing you need to find is we need to find the angle. For the angle, I'm going to use you can use sine, cosine, anything you want. So here's the Q. I want to use the sine just because. Sine Q equal, the sine is the opposite over the hypotenuse, 5 over 5.8. What would that give you? 5 divided by 5.8 equal 0.86. 0.86. Then reverse function that and find sine inverse 0.86. So where's my sine inverse here? Okay, shift sine inverse. I came up with 59.5. Anybody came up with something different? 59.5. So sine inverse, this value give you 59.5 degrees. Okay. Any question guys about finding, the most important thing really is here is finding the degree and finding also the distance. So from these two values we can plug them in. Any question, Tao, Ashley? Finding the degrees and finding the distance? The angle and the distance. The last thing, my friend, is go to the fig. We need to find the candela power. Candela power at what angle? The angle is 59.5. For this, you need to go to page 50, fig. What's the fig again? 5.3?
Yeah.
And what would that give me? 50, what did they say, 59? 59, I don't have 59, so my options are 55 or 65. 55, what did they say, 59, like 60. I'm going to go close to 60, I'm going to go to 65. So I'm going to go I'm going to make this one, guys, approximately 65 based on this, because I'm lazy to do interpolation. And based on 65, I have 780. I have 780 candela power. Any question guys about this? I went from 59 approximately to 60. From 65, I came up with 758 candela power. Now the rest is history. You just plug them in. Any question? Any question, my friends? What I'm going to do is I'm going to plug them in and find the answer. Anybody plug them in? 15.36. Okay. I'm just going to write them down after everybody's done with this one. All right, so let's go to the foot candle. So the last thing, my friend, is foot candle equal 7. You guys have to give me the values here. So I have 780 times sine. We know what the sine is because we found it. The sine is 0.86. 780. 780 times 0.86 . 780 times 0.86 × 10⁻⁷. 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 780 times 0.86 × 10⁻⁷ That's a sine multiplied by, what was the guard? 0.9 and times 0.85. Did I miss anything? Divided by the distance. What was the distance? What was the distance? 5.8. 5.8 squared. If you do the math, would you come up 15 point what? Again, 15.1?
There's no objection. It's 15.36.
15.3, 15.4. Anybody object? Anybody dare to object? No? 780. Did they do the 0.86 right? 0.86, yep. I think I didn't miss any this time. Anybody came up with a different answer, guys? This number here was the sine, because I really calculated the sine. Might as well stick it in there instead of putting the sine of, right? So 15.4, that's a lot of light. Why? It's billboard, you know, it's a vertical light. And don't forget to put V here. V stand for vertical foot candle calculation. Any question, my friends? Any question? I thought just because before I let you go, if you guys go to Lithuania, they have tons and tons of fixtures that you can look at. I grabbed the floodlight. Was it my floodlight here? No, not this floodlight. Here's a floodlight, guys, that Lithuania have. And it's a metal halide. You can buy it from 3200 watt, 320 into 1000 with a high pressure sodium. A lot of catalog description, but here's my favorite is, it will give you the distribution curve for it, the candela power. I want to bring to your attention, I don't know, most of us don't pay attention to this, guys. Most of us don't pay attention to this, Chris. If you look here, it says vertical candela power and horizontal candela power. The reason why don't we pay less attention to this, because we have the software. We pull the IES file and put it in. But if you look at this, so the dark line is actually vertical, and right in here, Oladipo, it gives you the distribution from the beam. When you, here's the 0, that's my 0 point. So if you go right at the 0 in the front of the fixtures, it will give you, this is this amount of, this is candela power. Look how much you can get. This is, you can get that amount of power right in front of the equipment. So it give you the lumen based on how far are you from the, are you to this side or that side from the beam, and how many degrees are you away from the aiming beam. Anyway, and I'm not gonna, so it gives you a couple of scenarios for a couple of heights and a couple of descriptions. So we rarely pay attention to these guys because of one little thing. We pull the IES file for them and off it goes. What I want to, okay, so off it goes with them. But I thought just to pull this floodlight for you. Any comments, any questions? Any comments, any questions? So Phil, you have a floodlight for whatever you want to do on a wall or anywhere. You grab it like we did. Make sure in visual it allows you to aim them. There is a place where you can aim it, and then you do your calculation. That's all I have. Any question, guys? For the test, get the formula, do the examples that we did, you're good to go.